Hello everyone, so in this video, let's talk about a middleware problem from LEETCODE. The problem name is count number of teams. So let's move forward. There are n soldiers standing in a line. Each soldier is assigned a unique rating value. You have to form a team of 3 soldiers amongst them under the following rule. You have to choose 3 soldiers among them which are standing in a line. As you can see here, these are the soldiers which are standing in a line and everyone is the rating that is given. They have to be chosen according to the following rules. Choose 3 soldiers with index I, J, and K with rating of I, rating of J, rating of K, such that a team is called valid if the rating is strictly increasing among the 3 soldiers or strictly decreasing among the 3 soldiers, such that the IDs has to be and has to be between the range of 0 to N. So in simple terms, you have to just choose 3 soldiers which are like strictly increasing or strictly decreasing. Okay, and they should be having let's say one after another. So IJK should be like in a, you can say it's some sort of like a subset you have to choose among these soldiers, such that they should be strictly increasing or strictly decreasing. That's the complete logic, not logic, the problem. Return the number of teams that you can form under the following conditions. Okay, and you can see that we have n equal to 1000. So when you have to generally choose 2 elements, or actually not 2 elements, you have to choose 3 elements. What you try to generally do is that you try to choose 2 elements, because as you can see you have n equal to 1000, which means that you can do an O of n square approach. When you can do an O of n square approach, what you can do is that you can either do 2 types of things. You can do O of n square log n approach, in which you try to choose 2 elements and then try to find out the third element in some sort of a logarithmic manner. But in this question, you can also do it in O of n square. How can you do it in O of n square? Like generally, if you want to find out 3 elements, you can do it. You should not be doing it in O of n cube, that because that will go out of you can say time limit x. But you can do it in O of n square of O of n square log n. But try to then force your question complexity into both of any of these type of logic. Now, how can you do that? What you can think of is that when you try to choose 1 or 2 elements, you have to iterate over them and try to like fix that I will choose this element. So let's say I have these elements. Now instead of choosing the first 2 elements or the last 2 elements, what it's better is that it should be strictly increasing or strictly decreasing. So you can choose the middle element. Like always try to find out the permutation which suits your approach best. You can either choose the first 2 elements, the last 2 elements, or the middle element, whatever suits best. There are only few permutations you can think of for such type of problems, a subcategory of problem in which you have to choose 3 elements. So if you choose the middle element, which means that if you fix the middle element, let's say I fix this element, not this element. Let's say I fix this element, this 5 element, which means that I have to somehow find all the elements which are smaller than 5 on the left hand side and all the elements that are larger than 5 on the right hand side, and vice versa. Means that all the elements larger than 5 on the left hand side and all the elements smaller than 5 on the right hand side. This can be done in O of n, which means that you can just do a for loop from left to this particular element, find out all the smallest and largest, then this element. Similarly, go a for loop from this to last, find out all the elements from large, like smallest and largest among respect to this element. So you are doing a for loop over every element that is the middle element, that is done in O of n, and then you're again do an O of n to find out the smaller and larger on both the side of these ranges. So again O of n. Now, how can you find out using this? When you find out the smaller elements, so you have 2 options. Either you can, like when you are choosing this element, you will choose the smaller on the left and larger on the right. So all of those permutations will be possible. So let's take an example. Let's say you have this 5. So you have to find out all the elements that are smaller than 5 on the left and larger than 5. Smaller than 5 is 2 and larger is nothing. And all the elements that are larger than 5 on the right hand side is nothing, and smaller than 5 is all of these. So When you take 2, you can only match it with the number that is larger than 5 on the right hand side. There is nothing, so it cannot be matched, because if it is 2 and it is 5 in the middle, that I'm forming the 3 elements, the 3 teammates, then all the elements on the right hand side should be larger. If we have 6, that can form a team. If we have 2, 5, 7, it can form a team. 2, 5, 8 can form a team. So all the elements that are larger can form a team. Number of elements on the left hand side that are smaller will be multiplied with all the numbers on the right hand side, so that I can form all the possible permutations of the number of teams I can get, because all the smaller elements can be mapped with every larger element on the right hand side, and vice versa. And then you can add all the teams that you have possibly formed and just return. That's the complete logic for this particular problem. Let's move on to the code part now. So what we have done is that we have to count out the number of teams, so count equal to 0. Then what we have done is that we have iterated over from 1 to n minus 1. Why? Because we have to take, like you can say, the middle element. So the middle element will be such that there should be one element on the left hand side as well, like at least, and one element on the right hand side. So you should, like you can say, buffer out one element on the left and right element. Okay. Then what you can see is that you have to find out the number of elements on the left and right that are smaller and larger. So we have created two, like you can say, arrays according to that of index 2, which means that it has two elements, smaller and larger. So which means that now I will go iterate over all the left elements from 0 till I. Okay. So because I is the current element that I'm doing this outer for loop, that is the middle element. And then from 0 to the middle element, less than the middle element, I will find out all the smaller elements store in left 0 and large elements left 1. So that is how I can find out all the smaller and larger elements with respect to this ith element on the left hand side. Similarly, on the right hand side from I plus 1 till. Okay. Then the number of possible pairs that for left and right I can form is smaller on the left, larger on the right, and larger on the left and smaller on the right. These are the two possible combinations I can form. Just add them and count. That's it. That's a print. That's the only logic and the code part for this particular problem. If you still have any doubts, you can mention in the comment box. So total, you can say, time complexity is O of n square for this particular. Thank you for this video till the end. I will see you in the next one. Coding.